right. Here you go. So I want to spend some time going over the first front and back of this. By the end of the week, hopefully we'll have this done as a class. I'm not having you actually do this outside of class. I'd say take notes on this. So this page, folks, this page, I would say definitely make your note cards based off of these. Make sense? Yes. You can't have this on the final. Oh. But sure. No. No. I have to do everything in my power to get freshmen to pass. So you guys know how to pass. All right. So I'm looking at problem number 1 on this packet. So let's talk about it. It says a researcher wants to study whether or not humidity levels have been increasing in the Denver area in the past decade. Identify the variable. What do you think? Humidity. All right. I guess you could say Denver as well, because, but I'm going to kind of put a question mark with that. See if here you, Swanee. It's like talking to my wife. He ignores me. Wow. So as you come in, I said, "Here you go," and he just kept going. I said, "It's like talking to my wife. Just ignores me." Yeah, it happens. All right. Describe what an observation might look like. Well, an observation could do one of two things. We see change with humidity, or we don't. Okay? I mean, those are both things that could happen. I mean, I'm not here to say it is happening or it's not. I'm just saying these are things that someone might look at. So that's pretty simple. Problem number 2, though, says, here you go. Problem number 2 says, for what? So see change in humidity, or we don't. One or the other could happen. Okay? And then number 2 says, identify each as categorical, quantitative, and identify the quantitative variables as discrete or continuous. Oh my goodness. So, temperature. Quantitative. And is it discrete or continuous? Yeah, because all of the temperatures in between whole number of temperatures take place. Continuous. That says continuous if you can't read stirrup. So that's for temperature. B says hair color. Yeah, it's definitely categorical. C, student ID. Here you go. Yeah, why is ID categorical? Yeah, it's different for each person. I mean, you're labeling. You okay?
Yeah.
Okay. So, an ID, each of you has an individual one. So it's categorical. It wasn't that. You look at that. Price of gas. Quantitative. Now, here's the tricky one. Is it discrete or continuous? What do you think? Discrete. It's discrete, and some people might argue, but there's decimals. You're right, there are decimals. But it's not decimals, 15, 20 decimals in length. It's, $3.51 and 9/10. So they have a decimal with a fraction thrown in there. Gender? Yep. Categorical. And then number of siblings. I'd say it's quantitative, yes. And I hope it's discrete. Now, I know some of you say, well, that's my half brother, but that's not what they're talking about when they do that. It's not a physical half of a person. So, all right, does that seem good? What'd I do? Okay. I'd say 2. All right. Explain what separates continuous from discrete. Okay? Discrete, you are just counting. Okay? So discrete could be money. We said gas price. Things like that. Continuous, OUS, could be like your weight. Even though your scale measures to maybe 1/10 of a pound, all of those things fall in between. Temperature, things like that. Things that, if I walked into this classroom and said, how many people are in this classroom, that is a discrete kind of data. Continuous would be like, hey, what's the temperature in this classroom, from 8 a.m. till 3 o'clock, 3 p.m. The temperature fluctuates. It goes up and down a little bit. It's within the same parameters, but it still kind of goes up and down. Number 4. Name the 2 data displays that are appropriate for categorical variables. Go back and look in your notes. What do you got? Bar graph. I like bar graph. I go with a pie chart. I think those are both good. Go with both of those. Sweet. Hey, friends, we just got done reviewing the very first page of this, 11-page packet. 11. So I'm going to just do the backside, and then we're going to go over the homework, the 4-1, and then I'll teach a little bit more on 4, and we'll see about it. All right. Number 5, we wish to show the percentage breakdown of colors of M&M candies in a bag. So 25% red, 20% brown, etc. Would a circle graph be appropriate for this data? Yeah, why would a circle graph be good? Categorical. Categorical. Yeah, we have the percents that are dealing. So we want our pie parts to be a percent. Okay? Good job. See, we don't even have to review this. You guys are knocking this out of the park. Describe the difference between a bar chart and a histogram. Do what? Okay. What would be the difference if we looked at it? Is this the bar chart? And then the histogram is this? Yeah. And then the same thing happened, and I didn't draw it the correct way, but the width, all the widths need to be the same. It's just bar chart, you just have, here you go, and then histogram, they're all together. Okay. 7. Ooh, number 7. Which would work better for our information? So we have all of these numbers. Which display would work better, a dot plot or a stem plot? Stem plot's box and whiskers, right? Why would a dot plot not work? Well, I guess it would work, but yeah, I mean, if we were to do a dot plot, we would have to say, you could do something like this where, 0, 10s, 20s, 30s, and you just count. So I got a 7, any others, 11, 18, 15. So this one, dot plot's not going to show too well. I would say you definitely want to do a box and whisker, which is what they call a stem plot. There's no E at the end of plot, sorry.
Wait, what's the one when you have the two columns?
Two columns.
You have like many 30s, you have 3 on one side and then 2, 5, 6. Yeah, like on the right side, you have like 0, 1, 2, 3, and on the other side, you have like 10 and 20 or whatever, like 35, and you count all the values that are 30. So it's like a
That would be like a dual dot plot. So that box and whiskers should be this, where we know that you have a minimum. 25% of your data is here. 25% of your data is here. This is called Q1. This is called Q2, which is also called the median. This is Q3. 25% of your data fits here. And then here's your max, which has 25%. There is something that is called an outlier, but we'll see if we review that later.
So start this, but then we'll be doing dot plot.
Yeah. So you go this way. So you're if you were to say, you know, how much money is in everyone's pocket, and you break it up to boys and girls, something like that. And
That's not what we're talking about. It's like if you have a set of data.
you have two pieces of data.
No, you have one piece of data, and so you have like 5 things of.
And you're saying that's a dot plot?
No, I thought that was a stem plot.
Well, let's see. Stirrup has been wrong often. So I'm just going to flush out the book. So what am I looking up? Stem plot?
Yes.
Should be in the beginning. Explain. Axis. Numerical. Maybe histogram. Histogram. Stem plot. Oh! You guys are the best. Okay. You know? You guys are the best. Okay, so dot plot. Am I right with dot plot though?
Yeah.
Okay, and then
Yeah.
and then a stem plot is this. Oh, you guys are so cool. So you'd have like this.
I thought 12, 18, 23, 24.
Yeah. So yeah. I didn't. I got lucky on this one. I did 11. There's an 11 in there. I was just making up numbers. Yeah, that's the stem plot. So which display would work better? I think it's stem plot because this is just you're counting. You know, you just have dots on how many would be single digit from the 10 to 19, 20 to 29, 30 to 39, so on and so forth. Stem plot would be better because you could actually identify, say, oh, this goes with 7 or 11, or we don't have a 12, do we? We do have a 12. Do we have an 18? We have an 18. So I think the stem plot would be better because you can see actual values. This is just counting. Oh, I love you guys. Which two quantitative data displays maintain the entire data set? What do you think of that is? What do you think? I don't know. This is escaping me, so I might have to look this one up. Anyone know?
I mean, isn't it asking which one shows all the data? Which ones are quantitative? Well, wouldn't that be a stem plot? I think quantitative stem plot. Well, no, because histogram doesn't show all the data. Does it count, there's a range between data points?
Okay.
It's still
So why don't we do this? Let me come back. I need to go check with my colleagues on that number 8, and I'll come back with a better answer for you come tomorrow. Which quantitative displays have handle very large data as well? Box plot? Okay. Maybe. Why don't I verify these? Maybe. Well, I'm going to look up 8, 9, 10, 11, and we'll come back to them tomorrow. Cool? But I put this in a safe spot. Don't be like my freshmen who will lose it before they even get out of their seat. I have attendance right today. Let's see. Josh not here. Alec not here. Hayden not here. No. All right. So 4-1 we did, right? How did you feel about 4-1? Somewhere in here. And then if you missed this past Friday, there was a quiz, right? Test? Test. That's what we did. All right, so let's see how we do it here. So stat analysis, you roll an 8-sided die with the numbers 1 through 8 represented. I have no idea what an 8-sided die looks like, but there's 8 sides to it. Okay, oops, 4-1. So number 1, you have an 8-sided die. So what's the probability you roll even? Well, being you would have 4 odd and 4 even numbers, you would have a 4 and 8 chance, which is a 1/2 probability of rolling an even number. And then B, what is the probability you roll less than 7? So that means we're not including 7. We're just going less than 7. So 1, 2, 3, 4, 5, 6. So that would be 6 out of 8, which is 3/4. Okay. When should you switch one of these to a percent? It doesn't really matter. There you go. This is a review we started on.
Thank you.
But not on that now. I'm going over 4-1. Ooh, I had a nice trip. I'll see you guys next fall. Okay, problem number 2. Let's see. You flip a coin. You roll a die and you flip a coin. Okay. So I think this one, a single die, is a 6-sided object. I don't think we're referring back to the 8-sided one. And a coin, you have heads, tails. Okay. Sample space, we're talking about one situation. So I can do it one of 2 ways. 2, 3, 4, 5, 6. You go heads, tails, heads, tails, heads, tails, heads, tails. This is just a way of representing it. The other way you could have done it is I could have went heads, tails with 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5, 6. Either way is appropriate way of representing it. Probability in this situation, rolling a number greater than 2 and a heads. So greater than 2 and a heads. So you're talking about here. Greater than 2, there's 3, 4, 5, 6, and a heads. So if I count how many of these are, there are 12 outcomes. So this is letter B. There's 12, letter B. There are 12 outcomes. 4 of those, because if I count all these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, these would be all of the ones that we want. So there's 4 of those. So reduce your fraction, so you have a 1 in 3 probability of rolling a number greater than 2 and a heads. And then probability of rolling a number greater than 2 or a heads. Was this the one we got stuck on last time? You guys were asking me about? Okay, we can do it. Okay. All right, because I went back and researched it. Okay, greater than 2 or a heads. Greater than 2 or a heads. So we want the greater than 2. So we're talking about this or a heads. So one or the other. I'm going to use all of those outcomes. So 2, 4, 6, 8. I have 8 and 12, which is 4 goes into both. 2 and 3 probability of that taking place. Because I can have the tails as well. I have one or the other. One or the other. So I'm pretty sure that's how we'd represent it at this juncture. I think we could debate it later, but that's where we're taking place there. 3, you roll 2 dice, sample space. The 2 dice, I like doing this way. Some of you like to draw the actual dice themselves, but if you do this, add them up. 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. And 7, 8, 9, 10, 11, 12. So that's basically our sample space. The red is the summation of the 2 die, die 1, die 2. So probability of rolling the sum of a 4 of an 8 or an 8. 4 or 8. Okay? So 4, I have 1, 2, 3. And 8, I have 1, 2, 3, 4, 5. So I have 5 and 3 is 8. So I have 8. I have 36 outcomes. I can reduce that fraction. 4 will go into both. 4 goes in there twice. 4, 2 ninths. 2 to 9 probability of that taking place. Letter C. Rolling a sum less than 9. Less than 9. Okay. So I can do this one of 2 ways. I can count up the 8s, the 7s, the 6s, the 5s, the 4s, the 3s, the 2s, and the 2. Or I could say less than a 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 outcomes happen to be bigger than 9. There happens to be 36 outcomes. So that's going to be 26 out of 36. So that's going to be 13 out of 18. 13 out of 18 probability of rolling that. Letter D. Probability of rolling a 6 on at least 1 die. Okay, I can roll a 6 on both as well. Okay, so I'm going to pick a column. Probability of rolling a 6 on at least 1 die. But then I'm also going to take into account this. Notice one of the regions included the 12. The other region I circled, I don't want to count that 12 twice. So I have 6 outcomes here, 5 outcomes here. 6 and 5 is 11. So I got 11 out of 36. That won't reduce. D. Probability of rolling. Oh, wait, didn't I just do that? I did that one. Probability of rolling even on both. Okay, so that means you rolled a 2 and a 2, a 4 and a 4, a 6 and a 6. Those are all even numbers. Am I seeing that right? D. Probability of rolling, no, E. Probability of rolling an even number on both dice. So this is 1 outcome, 2 outcome, 3 outcome. So I have a 3 out of 36 because that's my sample space. I have a 1 in 12 probability. F, rolling a number larger than 4 on both die. All right, I'm going to go back to my thing. I want larger than 4. So I'm going to have this one and this one. Oops, I don't want to go to there. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So I have a 10. 10 and 36 probability, which is 5 out of 18 probability of taking that. And I'm just going by counting on my sample space. You have a 4-sided die, which that would be 4 triangles, and a 6-sided die. Again, leave the grid with blank squares. Okay. So a 4-sided die would be this. That's one thing. And then my 6-sided die would be this one. So this would be a 2, a 3, a 4, a 5, 3, 4, 5, 6. And that, I'm just adding them up. 4, 5, 6, 7. 5, 6, 7, 8. 6, 7, 8, 9. And then 7, 8, 9, and 10. That's our sample space. We had those 2 particular die. So the probability of rolling a 7, 1, 2, 3, 4. 4, so probability of rolling a 7. There are 4 of those outcomes. There are 20, 1, 2, 3, 4, 5, 6, 24 outcomes. So you have a 1 in 6 probability of rolling a 7 in this case. And again, you're still trying to figure out the thing. Rolling, ooh, difference of 2. Okay, difference of 2. What does that mean? Like a 3 and a 1? Oh, wait.
You're asking, like, what is the probability of rolling a number on the 4-sided die that can be subtracted from a number on the 6-sided die to get 2?
2? Okay.
Like 6 and 4, or 3 and 1, or something.
Okay, so let's see. 6 and 4.
I think those
And
are
then
the
5 and 3.
Yeah.
4 and 2. 3 and 1. Is there any other ways we can make that happen? So you have that. And then 1 minus 1, 2 minus 1, 3 minus 1, 4 minus 2.
Or is there only 4?
Is that right?
I mean, that's what I thought it meant.
So 3 minus 1 we have. 4 minus 2 we have. 5 minus, yeah, geez. So that's 4 out of 24 outcomes, so that's also a 1 in 6. Am I right there? I'd never experienced that kind of problem before. We'll call it good. And then the probability that the 4-sided die is greater than the 6-sided die. Okay, so 4-sided die is greater than the 6. So 4.
Will you want to take out 4, 5, and 6 for the 6-sided die? And just completely eliminate those.
So we have that, right?
But wouldn't you have to take out the 4 as well? Because you only want value that's greater than.
Yeah. I don't like that problem. I'm not going to do it. All right. The rest are good. All right. So we should be good on those. Let's take a look at 4.2, independent. So I had a bunch of students that came up to me and said, they are in my second period class this coming semester. Do any of you have me for a second period class as well? It's a bunch of seniors. Because I don't think I have class second period, so I either have 45 student assistants or.
No, you're not.
All right, so I think they're confused, and it's sixth period they actually have me. All right,
Unless your schedule got changed, but no.
that always could happen too. All right, statistical analysis 4-2, independent probability. Independence is a crucial concept in both probability and statistics, and introduced for the first time here. To calculate the probability of an event in multiple outcomes must occur in sequence. We need to know the probability of each outcome. The events are independent and straightforward. So independent, so let's keep that in mind. Consider a person who's flipping a coin 3 times in a row, recording the result. If he gets a heads on the first coin flip, does it affect the probability of getting a heads on the second? No, the coin doesn't remember. Okay? So rolling dice, flipping a coin, these objects don't remember what happened last time. Okay? And a lot of people think, oh, well, there's a streak. It's going to happen that way. It doesn't remember. Independent events A and B are events in which the outcomes of event A have no effect on the probability associated with event B. So this would be like flipping a coin and drawing something out of a deck of cards. They don't have any effect on each other. Or rolling a dice and pulling it out of a card. So it says if you flip a coin and you roll a dice, the result on the coin flip will have no effect on the probability associated with the dice roll. If you want to have the Avalanche and Nuggets to both win their respective championships this year, the result of the Avalanche winning will have no effect on the probability with the Nuggets winning. So that kind of going a little game theory on you. Independence is tricky, okay, but if you want to calculate it, basically they use this. If they wanted to have 2 independent events, this little upside down thing stands for and. And so this is the probability of the first event taking place times the probability of the second event taking place. So if we said, what's the probability I get heads and pull an ace out of a deck of cards. So the probability of heads has no event on the probability of pulling an ace. So you have to kind of know. Probability of heads, 1 out of 2. Probability of pulling an ace is 4 out of 52 because there are 4 aces in a standard deck of cards. Yes, you can go ahead and reduce when needed. This would reduce to 1 out of 13. Then multiply top to top, bottom to bottom. So you'd have a 1 in 26 chance of flipping a coin, getting heads, and shuffling a deck of cards and saying, it's an ace. Nope, it's a 3. Okay. The probability to roll a die 5 times, obtaining a 6 5 times. So if I wanted it, what's the probability that I roll or get a heads? Heads 6 times. Again, the coin doesn't remember, so you have 1/2 times 1/2 times 1/2 times 1/2. 1/2. And my 1/2s get progressively bigger, or 1/2 raised to the 6th power. So 2, 4, 8, 16, 32, 64. P of probability. Yeah, P parentheses means we're doing a probability of something. Yeah.
Can we just make the whole final just unit 4?
Unit 4?
Yeah. I feel like everyone would agree.
What I'll do is, what I was planning on doing is I was going to bring in poker chips, and you get that many poker chips based on what your grade is, and you get to gamble on card game. Your grade. So all of a sudden I get a phone call from our parents saying, hey, look, my kid put it all in because they were showing they had a good hand, and they lost it all, and they got an F now. Yeah. Maybe a great statistics lesson.
I think they would deserve it. Tell you not to gamble or gamble.
Yeah. All right, so good there. So let's do this. Let's have you. I think I've done enough of damage for today. You guys want a lot of homework tonight? Okay, cool. Yeah. Yeah, we'll do a lot of homework. Just, because I'll be that teacher saying, hey, we have to make up everything we didn't catch. It's always silly to me. All right, what do we say we do page 205? And will you try 1 through 4? That a deal?